Hey guys, welcome to this small introduction of continuity. I think I'm not going to work out any examples in this one. I want to introduce you guys to some of the terms and familiarize yourself a little bit with what it means to talk about continuity and to say if a function is continuous or discontinuous and what kinds of discontinuity they are. So, what does it mean for a function to be continuous? Well, there's the simplest way to put it is if these three conditions that are listed here are met. Now, if we're talking about a certain point, then we can say, how do we know if a function is continuous at that point? Well, in this case, let's say the point is C. So it's continuous at C if, number one, if the function evaluated at C is defined. All right? So if we plug in C and we get an undefined point or an undefined function, we have a problem right away. So that will immediately say it's discontinuous. The second condition that has to be right is the limit of f as x goes to c of f of x exists naturally. And the third one is that limit has to be f of c, which is very closely related to the first condition. So that's why f of c is right away an alarm that should tell you if it's continuous or discontinuous. So, and now this we just spoke about continuity at a point. Well, what about if we are told to look at an open interval, like perhaps over here for f of x is 1 over x. We have this nice graph here, and it tells, look at this open interval between 0 and we can even go to 2 for this example. So 0 and 2. And it says here, well, if a function is continuous on an open interval, it has to be continuous at each point in the interval. Now, for open intervals, we don't include the endpoints. We don't evaluate their continuity at that point. So in this case, this is a bit tricky, and we'll talk about closed intervals in another example. But here, the only point that would really give us problems is which one. For if we evaluate continuity here, we say, is f of 1 defined? Yeah, all of them are defined except f of 0 in this case. But we don't include it in this one because it's an open interval. So this function is continuous on this open interval. So this checks out. So now if one of these conditions isn't met, then we have to think that we're obligated to think that the function is discontinuous. So let's say one of those conditions fails, then what kind of discontinuity do we have? Well, there are two kinds actually. The terms are removable and non-removable. And removable means that if we're looking at this point x equals c, and we suspect that it's not continuous there, then it's removable if I can make the function, if I can redefine it so the function is continuous at that point. What am I saying here? What I'm saying is, if there is an alternative way, maybe we can look at this example here. For this function, I hope you can notice the small hole here. There actually is one, right? If we're looking at this function, let's start here. We can say, is this function continuous? Well, is where? Let's look at it between maybe 1/2 and 1/2. And we're going to say, well, this function seems to have a problem at 1, obviously, right? If you look at this denominator would be 0 at 1. And up here, obviously, this is a point of discontinuity here. So f of 1 is not defined, so this is not continuous. So what kind of discontinuity do we have then? It's removable or non-removable? Well, according to our rule here, this is removable if I can redefine this function here so that it is removable. And unfortunately, I can't do that here. There is no way. The only way for that really to be right would be if there was maybe another point here, and I wish I could fill that in. If this was a defined point, this would be called removable. in this case. So what do we have here? Well, in this case, it is removable if we add this point. But if this weren't here, go back a few steps. Right now, this is non-removable then. According to our definition, because it can't be redefined. That's the way the function was given to us, and it's undefined there. The limit does exist there if we went right. The limit would be 2. So that gives us a bit of a problem. 2 of the conditions are okay, but the first one is not, and all 3 must be met for it to be continuous. This is not continuous, so it's a type of discontinuity, and in this case, it's non-removable because the function cannot be redefined there. So watch out for the videos that are coming. I'm going to just work out some examples for you guys that are solving problems. But if you understand this and you just want to see some examples worked out, or if you have any questions, post. And thank you for watching.